So today we have a nice problem related to the exponentials. The question over here is to find the value of 1 upon x plus 1 upon y plus 1 upon z if 2 to the power x equals to 3 to the power y equals to 6 to the power negative z. So this is Anmol, and now let us see the solution. How can we solve this problem? So first of all, let me tell you a thing that I will be presenting two methods to solve this problem. So let us see the first method. Now I will start the first method by equating 2 to the power x equals to 3 to the power y equals to 6 to the power negative z equals to a fourth variable k. Okay, this was the given data and I equated this thing to another variable k. Okay, now from this thing we can clearly say that 2 to the power x is going to be equals to k, 3 to the power y is also going to be equals to k, and 6 to the power negative z is also going to be equals to k. And these three equations I will simply take natural log on both of the sides. Therefore, natural log of 2 to the power x equals to natural log of k. The second equation will turn out to be natural log of 3 to the power y equals to natural log of k. The third equation will turn out to be natural log of 6 to the power negative z equals to natural log of k. Now to simplify this thing further, I will use the logarithmic rule, that is natural log of a to the power b equals to b times the natural log of a. So the left hand side will turn out to be x times the natural log of 2 and this thing equals to natural log of k. The second equation will turn out to be y times the natural log of 3 and this thing equals to natural log of k. The third equation will turn out to be negative z multiplied with natural log of 6 equals to natural log of k. Now in these three equations, I will simply try to isolate x, y and z in the left hand side. So for that, in this first equation, I will divide both of the side by natural log of 2. Therefore, the value of x will be natural log of k upon natural log of 2. Similarly, the second equation, the value of y would be equals to natural log of k upon natural log of 3. And in the final equation, the value of z would be equals to natural log of k divided by natural log of 6. And remember that it was negative z, so I will move this negative sign from the left hand side to the right hand side. So negative natural log of k upon natural log of 6 is the value of z. So here we have got the value of x, y and z. So let us replace x, y, z in this equation with this value. So 1 upon x will turn out to be natural log of 2 upon natural log of k, plus 1 upon y will turn out to be natural log of 3 upon natural log of k, plus 1 upon z. So the value of z is negative. So this plus sign will simply turn out to be negative first of all, and 1 upon z is there. So I will reciprocal the value of z. So it is natural log of 6 divided by natural log of k. Now all these three terms, the denominator is common, that is natural log of k. So I can take it natural log of k as a common denominator. In the numerator, natural log of 2 plus natural log of 3 minus natural log of 6. Now to simplify this thing further, I will use the logarithmic identity, that is natural log of a plus natural log of b equals to natural log of a times b. So here we can see that natural log of 2 plus natural log of 3 is present. So this thing will turn out to be natural log of 2 times 3 and that is 6. So it will turn out to be natural log of 6 minus natural log of 6 that is present over here divided by natural log of k. Now the numerator part of this equation becomes 0 and 0 upon natural log of k is 0 itself. So we can see that by using the first method, we have got the value of 1 upon x plus 1 upon y plus 1 upon z and that is equals to 0. Okay. Now let us see the second method, that is much more better than this one. Now in the second method also, I will equate 2 to the power x equals to 3 to the power y equals to 6 to the power negative z equals to k. Therefore 2 to the power x equals to k, 3 to the power y is also equals to k and 6 to the power negative z equals to k. Now you can see that these two steps are common between these two methods. Okay. Now instead of using the logarithms, we will use the exponentials over here. So we have 2 to the power x equals to k. I will simply take the power of 1 upon x on both of the side. So I will get 2 to the power x into 1 upon x equals to k to the power 1 upon x. Now x and x got cancelled out. So we finally get the value of 2, that is k to the power 1 upon x. Okay. Now in the second equation, we have 3 to the power y equals to k. So from there we will get the value of 3, that is k to the power 1 upon y. And from the final equation, we will get the value of 6, that is going to be k to the power negative 1 upon z. Remember that 6 to the power negative z is present, okay? Now here we have got the value of 2, 3 and 6, and this can be related very beautifully. Look carefully that 6 is ultimately 2 into 3. So now this value of 6, 2 and 3 can be replaced in this equation. Therefore the value of 6 will turn out to be k to the power negative 1 upon z equals to 2 into 3. Now the value of 2 is k to the power 1 upon x. Therefore k to the power 1 upon x into k to the power 1 upon y, that is the value of 3. Now remember the property of the exponential, that is a to the power m into a to the power n equals to a to the power m plus n. So this property can be utilized in the right hand side of this equation. Because the bases are same, therefore we can add the power. So k to the power negative 1 upon z equals to k to the power 1 upon x plus 1 upon y. Now we can see that the bases are same on both of the side, hence we can compare the powers. Therefore negative 1 upon z would be equals to 1 upon x plus 1 upon y. I will simply add 1 upon z on both of the side. So the left hand side will turn out to be 0, and on the right hand side we will have 1 upon x plus 1 upon y plus 1 upon z, and that's the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me or else you can send it to me on my Instagram. The link is in the description.